Let's suppose you have invested some money in a bank. In the first year, the interest earned on the investment is 18%, while in the second year, the interest earned is 20%. So what is the average growth rate of return per year? Generally, by default, arithmetic mean implies average. In the given situation, one might think of taking the arithmetic mean. However, an accurate rate of return cannot be computed using the arithmetic mean. The reason for this is that applying an 18% rate corresponds to multiplying the sum invested by 1.18 rather than using addition. Likewise, applying a 20% rate corresponds to multiplying the sum invested by 1.2. In these cases, the average rate of return is calculated using the geometric mean and not the arithmetic mean. Let's look at the geometric mean and how it is computed. The geometric mean, g, of any two numbers a and b is given by the square root of the product of a and b. The sequence a, square root of ab and b forms a GP with the common ratios as shown. Therefore, we get an average rate of return by calculating the geometric mean as shown. So the average rate of return is 18.97% per annum. Note that all three numbers are in GP. Mathematically, we can obtain the geometric mean of two numbers much as we do the arithmetic mean, except that the numbers are multiplied and then the square root of the resulting product is taken as shown. Hence, the average rate of return per year is 18.97% in this case. We can conclude that the geometric mean g of two numbers a and b is given by the square root of the product of a and b. Also, the number a, the square root of the product of a and b form a geometric progression. In other words, if three numbers are given in GP, then the middle term is the geometric mean of the two numbers outside. For example, the geometric mean g of two numbers 4 and 9 is 6, which is the square root of the product of 4 and 9. Therefore, the sequence of numbers 4, 6 and 9 is in GP. Similarly, the geometric mean or GM of 3 and 9 is 3 root 3. As of now, we have seen that when inserting one number between two numbers, we can generate a sequence in GP. Now, if we insert more than one number between two numbers, can we still get GP? Let's find out. We know that the geometric mean g of any two numbers is given by taking the square root of the product of two numbers. Let's consider two numbers, 36 and 576. We get the geometric mean of 36 and 576 as equal to 144. As a result, we get the geometric sequence 36, 144 and 576. Now consider 36 and 144 and find their geometric mean. By definition of the geometric mean, we get the geometric mean of 36 and 144 as equal to 72 as shown. Note that we get the sequence of numbers 36, 72, 144 and 576. Next, if we find the geometric mean of 144 and 576, we get their geometric mean as 288. As a result, we get a final sequence of numbers after inserting three numbers, 72, 144 and 288, between two numbers, 36 and 576 as shown. Now look at this sequence. Note that the obtained sequence is in GP with the common ratio 2. Therefore, we can insert more than one number between two numbers such that the obtained sequence forms a GP. Now let's generalize our observations by stating that G1, G2 and so on up to Gn are n numbers which can be inserted between two positive numbers a and b such that the obtained sequence of numbers is in GP. So a sequence of numbers a, G1, G2, G3 and so on up to Gn, b is a GP. Note that this GP has n plus 2 terms as shown. Now we have a as the first term and let r be the common ratio of the GP. Then the term b is equal to a times r to the power of n plus 1. As a result, r is given by equation 2. We know that G1 is equal to a r. Therefore, from equation 2, we get the value of G1 with respect to a, b and n. Similarly, we get the values of G2, G3 and so on up to Gn as shown. These are the required n numbers between a and b such that the sequence is a geometric sequence.